Hello and welcome to this video. Now on the 23rd of September 2016 I will be 32 years old. Also, I've been uploading videos to YouTube for about 9 years now. So in this video, which is not very long, I'm just going to be showing a number of different things. I hope you enjoy. We're going to look at some server parts, as I recently acquired a couple of servers and took them apart for the components. You have to excuse the shaky cam as I can't really set up my tripod at the moment. Let's start with good old RAM. So this is a typical stick of RAM from a desktop. It's quite old actually, DDR2, but that's a typical stick. And this is a stick from a server. You see how much bigger it is. Not all server sticks are RAM are this big, by the way, but this is a good example one that's oversized. So server RAM generally doesn't work in desktops. It has extra protection known as ECC, error code correction, I believe. Because you've got to think about it, take like a Google for example, you don't want the server to go down, so there's extra protection to make sure that there isn't any errors, or if there is, they are corrected. Power supply. Here is a server power supply from Dell. See, it's long rather than square like a typical desktop, and it's rated, get into focus, 5 volts standby, 2 amps, 12 volts, 41 amps. That's quite incredible. And these power supplies are really good if you can get hold of them. I think you can get it quite cheaply as well, because people repurpose them and use them to charge batteries and all sorts of stuff. I'm going to do something similar myself, but obviously be very careful. If you don't know what you're doing, don't even attempt it. But they're very good, very efficient power supplies. They're a little tricky to get working because they don't have a standard connector and you have to tell it to turn on and things, and there's like a enable lines and things, but there's quite a bit of information online, so if you know what you're doing you can reuse those power supplies, so that's very good, very useful. Other stuff, CPU, yeah. So again, this is quite old, but this is a typical desktop CPU, AMD Athlon, and over here we have a server CPU. Again, not all server CPUs look like this, but you can see it's quite different. There's extra circuitry on this, so that's interesting. Going back to the power supply, what is this odd block? This is called a DC to DC converter, which converts one DC voltage to another. I have another one here as well. These I can't find so much information about, but I'm going to try and reverse engineer. But basically what happens, you have the 12 volts from the power supply, then the CPU needs a particular voltage, it gets like a default voltage, then it talks to this DC-DC converter and says, oh hey, I need 1.2 volts, and DC-DC converter goes, okay, here you go, here's 1.2 volts. So it's like a variable power supply, again very efficient. Hard drive, yes. So the standards for hard drives in desktops nowadays is SATA, Serial Advanced Technology Attachment. Previously it was IDE, Integrated Drive Electronics, I believe. This is a SCSI hard drive. SCSI Small Computer Systems Interface. So the standard on servers pretty much is SCSI. Otherwise it's very similar hard drive otherwise. So if you want to use one of these hard drives, you're going to have a bit of a hard time unless you use it in a server. Basically what you can do is you can get an adapter. So I have one here. So this is called an SCA80, 80 pin, and it carries signals and power. So you'll need one of these adapters to convert to well, I think it's called SCA, it's just a 68 pin, and you provide power through Molex, and there's ID pins and stuff. But even if you have one of these, you then need an adapter to actually be able to use a hard drive. So you can get a PCIe adapter for your desktop, but just make sure it's not PCI X, otherwise you might have some trouble. And then you still got to sort out the cable, so it's not straightforward, but it's a fun project. Here I have from a Dell server, I think this is called a SCSI key, and it enables SCSI on your server. All it is a 1 kilobit, I think it's kilobit or kilobyte, serial flash memory chip. So a bit mean of Dell to do that, but you know, I've got a free flash chip, so I can't complain. there you go, just a little selection of server components I thought I'd show you. Maybe you taking apart servers yourself or be more interested in knowing more information, well, please leave your comments. Thank you. Now it's time for equipment overload. When you're working on electronics, computers, video game consoles and so on, you need your test equipment. One of the most basic is the multimeter. Here I have a Mercury MTTR01. It has basic tests such as voltage, resistance, diode, current and so on. The nice thing it also has is a USB port so you can log changing signals. I have another one which doesn't have the data logging. This is a Vicky VC97. Otherwise it's got very similar functions. These don't cost a lot of money, but obviously always research the equipment first to get a good deal. And you can start off quite basic, like this one for example, which is an A830L, and it doesn't even have the company on it, so ashamed of making it. It's two red test leads by the way, because one of them broke and I've had to use from another multimeter. But it's good to have like a very basic one that if it breaks, it's not the end of the world. For more specialist multimeters, for example, you have here an LRC meter 4070L, again no company. This measures resistance, transistors, capacitors and inductors. Very nice. This thing here, which is an MK168 transistor test, actually does a lot more. I brought it to measure the ESR of capacitors. Google that if you want more information about ESR. Here I have a peak component analyzer. This tests transistors, diodes and so on. The thing is, if you want to quickly get the pin out or just test a component, this is very handy indeed. You can connect the component any way up and it will tell you the pin out and information about it, and obviously whether it's working or not. And sometimes it's difficult to find even online information about a particular component, so it can be really handy to quickly look up. I'll talk about basic multimeters again. Here is an analog one, very cheap. Now the thing is, with analog multimeters, you can do basic functions without a battery and you can see a signal changing really easily, whereas on a digital multimeter that's not so easy. Something a bit different is torches. Now if you're inspecting something, you want a good torch. Now gone are the days you've got to have light bulbs and changing batteries. This is an XMLT6. It uses a rechargeable battery and it's pretty bright and you can change the focus as well. Another type of torch is a headlamp. Now if you're doing soldering or inspecting something, it's very convenient to have a headlamp. Again, this is LED rechargeable. It's pretty bright as well. The annoying thing about this is the batteries, two batteries are inside here, but it does have a built-in charger, but obviously that's extra weight on your head. And the other thing is that it cycles through the different modes when you press a button. Whereas this one, it just turns it on or off. You have to hold the button to actually change modes. But otherwise it's pretty good, and again you don't have to change batteries, just recharge. But that's a small selection of tools. What is this massive mess of wires, you may be wondering? Well, it's actually a fully functioning computer I built. It's based on the 6507 8-bit CPU, which is a cut down version of the 6502. It's documented on my website. It is an utter mess at the moment, but it does work. It runs at 1 MHz as well, which is probably all you can get away with all these wires, and it being on breadboard. A lot of it is actually the address and data bus, so as I finalise things, well, I've had to do a single board version, have been much neater. This is only temporary. So I don't know if you can see, there's actually a display in the middle. I've only used one limiting resistor, so it's not very bright. And I've used these Dell switches from a computer to count up and down, so you can see the values changing. I found the timing really difficult to do, because you've got switch debounce, so to clean up the signal, and then there's timing also in the code, so it doesn't respond too quickly. So there you go.